Dammam. Mehreen is from Dammam, I guess. Indian school. Mehreen Shafat. You don't know her? No.
Sir, I know her.
You know her. You know Mehreen. Okay. Then Yusra. Yusra also is from Dammam. You know Yusra also?
No, sir.
Not Yusra. Okay. So you know Mehreen is also from Kerala only, na?
Yes, sir.
So you are now in vacations. You're in Kerala, you said, no?
Yes, sir.
Achha. Sunday. So which chapter is going on here? Do you know that?
No, sir. This is my first class.
Hi, that too I know, but you are not being informed about it. Achha. Do you know which class is this? Which subject?
Chemistry.
Achha, you know that at least. Okay, fine. Good. Okay, you know at least that. Fine. So in chemistry, we are studying thermodynamics. Okay, we are studying thermodynamics. Now, in the last class, we had done 2 classes in which we understood a few things about terminology. Achha, have you done thermodynamics in school? Yes or no?
No, sir. I'm not attending.
You're not attending. What does that mean? Yeah, like you're a non-attending student? Yes. Yes, Nehra, you're not a non-attending student. Is that so? अरे ये नहीं है क्या? Disconnect हो गई. नहीं, नहरा तो है, but she's not answering. She's fed up. Okay, okay, we are done. Okay, internal energy we are done. I thought we are not done with internal energy. Okay, so internal energy is done. Modes of this is also done. Yeah, so these things are done. So I can start with a question, right? I can start with a question. Yeah. So in the last lecture, what essentially we learned is that a few things. First is delta U, which is the internal energy. It is equal to what? Whatever involvement of heat is there and whatever the involvement of work is there. Okay, and we also learned about another form, which is plus. This work can be written as minus of P external delta V. Right? You guys remember this? Yes or no? Do you guys remember this? Yes or no? No. Asma, Hamza, Hiba. What happened, guys? Hamza, you don't remember this?
The second one I don't.
Second one you don't. Achha, do you remember this? W is equal to minus P external delta V.
Yes, sir.
तो वही तो है, वही तो है भाई.
Sir.
और क्या
Yes,
है
sir.
है ना? Okay. Fine. So write a simple question first of all, but write it fast. In a process, 701 joule of heat was absorbed by the system. Okay, 701 joule of heat was absorbed by the system. Okay, now how to picture this? Think about a gas. Okay, and you are heating it. Okay, and think about a movable piston maybe. Okay, the piston is movable. Now, if we will heat, what will happen? Nehra, can you tell me what will happen? If I heat a particular system, then this piston will move up or down. Nehra, if you can answer me. Tell me, what do you think? Or you think nothing will happen? You don't know what will happen? Okay, is Nehra here or not? I don't think Nehra is here.
Sir, I
tell
don't
me.
know.
You don't know? अरे रे रे रे, ऐसे नहीं बोलिए ना. Try. You have to try. Okay. You have done. अच्छा, आपने ऐसे गैस चूल्हा ऑन किया कि नहीं कभी? Have you ever turned the stove on? Yes, Nehra.
So what?
Stove, burner, gas.
Yeah.
Have you have used that, na?
Yes, sir.
That means you know heat, how to heat something. You know that? Yes or no?
Yes.
Yes, you know that. Okay, fine, very good. Now let us suppose that you have kept a lid here. Okay, you have kept a lid here, and there are some particles inside this. Okay, it is completely packed, fully packed, and you are heating it. Then what do you think? The lid will be stable or it will be moving? Will it move? Yes or no?
It will be moving. Yes,
It
sir.
will be moving, right? It will be moving. Okay, that means these particles are pushing. Yes or no?
Yes, sir.
That means they are applying force.
Yes, sir.
Anna? Okay, fine. That's it. That means if I just change a bit of system, if I change the bit of system, and rather than looking at a lid, what I'm doing, I'm getting a bit more scientific, and I am using a piston. You know what is a piston? No or yes? Have you heard this
Yes,
word?
sir.
You know a piston, right? Movable piston. It means that piston can move. Now, what will happen if I heat this system? The piston will move up or down. Tell me.
It will move up.
It will move up. Okay, fine. So let us imagine that it moved till here. Okay, it moved some distance L. These particles were applying some force, and it moved till L. Okay, till L. That means what I can say is that, okay, fine. If I say this particle, this is a system. It's a system. Now you tell me, the system is doing work, yes or no? Because it is pushing something.
Yes, sir.
The system is doing work. Okay, now that means I can write, in a process 701 joule of heat was absorbed by the system, and 394 joule of work is done by the system. Okay, 394 joule work is done by the system. What change? What is the change in internal energy? Okay, so Nehra, you are saying that you have never learned any thermodynamics before this. Yes or no? Tell me.
Yes, sir.
You have never, na? But see, you can do this problem. Let me tell you how easy is this. So tell me, see, internal energy, you know that you have some internal energy, correct?
Yes, sir.
Okay, so what I am doing, I am giving you 700 joule of heat energy. Okay, fine. Okay, yes or no? Nehra? Okay, I'm giving you 700. And you are using how much energy to do the work?
394.
So how much will be left inside you? What should I do? Tell me, I will do that. You don't have to tell me how much will be remaining. Yes, Asma, that is right.
You have to subtract.
Subtract. Okay, fine. Go on. Subtract what from what?
701 from, no, 394 from 701.
We have to subtract. That means I have to take out 394 from 701. That is correct. But I will write it like this, na? 701 minus 394. Yes or no?
Yes, sir.
Okay, so this will be equal to
306.
306 or 7? I think 7. 307 joules. 307, na? 307. Because if I add 394, 7 चलेगा रख एक हाथ मेरा एक 9 इसका 0 हाथ मेरा एक 3 3 6 एक और 7. Correct? 307. Okay. Yeah. Okay. Now, Nehra, you do one thing. You open the NCERT textbook. Do you have NCERT textbook?
Yes, sir, I'll open it now.
You're opening it now.
Yeah.
Go to thermodynamics and go to exercises.
Okay.
I think this question. I think so. See there, na? There should be this question. I think this is from NCERT only, if I remember it correctly. Yeah, Khalid, correct. Question number 6.7 in the exercises. Did you see that? Yes or no? Yes, Nehra. No, Nehra is just finding out till now, I think. She's searching. Your mic is off, Nehra, by the way, if you're speaking. Okay. So all of you got 307, right? 307 joules.
Yes, sir.
Yeah, okay. What about Hiba? Yes, Hiba, you got 307?
Yes, sir.
You understood this, right? What is happening?
Yes, sir.
Okay, so this is the only thing which will be happening in thermodynamics. You will be giving some energy will be used. Sometimes that energy will not be used. So you have to keep all those things in mind. You have to keep all those things in mind. Okay. Nehra, did you find that question? Yes or no? Did you find this question?
Sir, just few more minutes.
Few more minutes. Arey bhai, go to exercise. I am giving you page number. Go to page number 189. Part 1. आप ऐसे ही बैठी हुई थी लगता है टेक्स्ट बुक. हाँ, you were sitting or no?
Sir, I didn't bring my textbook.
अच्छा, but you have your textbook now or no?
No, I have to take my laptop.
You have to.
Take my laptop.
You have to take. Okay, you don't have the textbook. You have it as a
No,
PDF.
sir. Yes, sir.
Buy. Can you buy it? Can you buy NCERT textbook or no?
Sir, if I
Nehra
have
has
to
blown
buy,
it.
then I'll.
You have to buy. Obviously, you have to buy. You are studying. You have to have the textbook, na? Hard copy.
No, sir, I came from Saudi, so I didn't bring my textbook. I thought I'll take it
Okay.
in laptop.
Acha, okay. So you have only for vacations. That is why you did not bring the textbook. Okay. बट यहाँ आके आपको लगा कि कोचिंग शुरू कर देते हैं, है ना? टेक्स्ट बुक नहीं लेके आते लेकिन कोचिंग चालू कर देते हैं. यू अंडरस्टैंड हिंदी, उर्दू लिटिल?
Yes, sir.
You understand it, okay. So the second generation Saudis, I mean not second generation Saudis, but second generation NRIs, even if they are from the south, they understand. Asma, you are also from south only, na?
Yes, sir, but I, predominantly speak Urdu only.
You're from Hyderabad?
Yes, sir.
Acha, that is why. Okay. जब तक नहरा लीव दैट, आपका लैपटॉप खुलेगा, आपका पता नहीं कब थर्मोडायनेमिक्स निकलेगा. ओके, लेट्स डू अनदर क्वेश्चन. ओके, यू फील यू कैन डील थर्मोडायनेमिक्स ना?
Yes, sir.
हाँ, थोड़ा. If you have used stove and gases, that means you can use you can deal with thermodynamics. Okay, let us all of us write a second question. Okay, understanding is the main part here. So write a question. 2 liters of an ideal gas. 2 liters of an ideal gas at a pressure of 10 atm. That means there are 2 liters of an ideal gas and the pressure which it has is 10 atm. That means the pressure of gas is 10 atm, expands isothermally into a vacuum. Isothermally into a vacuum until its total volume is 10 liter. Until its total volume is 10 liter. The first question in this is how much heat is absorbed and how much work is done in the expansion. how much work is done in the expansion. Okay. Acha, again, Nehra, do you have any idea what this question is saying?
Okay.
No idea. Na? You just answer me a few things. Okay. Just answer me a few things. So I have a system like this. Okay. Now I'm making it this way because I don't have much space. And let us suppose what is happening, that there is a piston here. There is a piston here. Okay. So initially it was 2 liters. Then it expanded, and it expanded so largely that the final volume was, what is the final volume here, Nehra? The question, can you tell me?
10 liters.
10 liter, है ना? तो थोड़ा थोड़ा तो आता है आपको, है ना? You can at least understand and read the questions. So 2 liter initially and 10 liters finally. Okay. And what it is saying, this word is important. Do you know what should be the meaning of this word, isothermally? Can you guess? Give me a wild guess. What will this mean? Isothermally.
The temperature of the system remains constant.
Yeah, very good, very good, very good. Correct. Exactly correct. And I'm really glad you used the very right wording, that the temperature is not constant, but it remains constant. Okay. Now the process is going on and the temperature remains constant. I hope Hamza, Heba, Asma, and Khalid Salman, they all also agree that the temperature is remaining constant. Okay. The temperature is remaining constant. Okay. So, Nehra, if I say, let us suppose you have a body. This is bolted, okay? This is completely bolted, and I am heating it. I am heating it. And there is another system which is open. There is another system which is open, and I am heating it. Okay, I am giving them, both of them, all of you will think, okay, I am giving both of them the same amount of heat. Which will have a higher change in temperature? The A or B? The A will have higher change. Okay, very good, very good. Okay, all of you agree that A will be having a higher temperature if we heat? Yeah, correct, Hamza, very good. A will have higher temperature when you heat. Very good, very good. That means the change in temperature will be very high in A, but it will not be very much in B. It will be not be very much in B. That means, can I say now, whatever heat I am giving to the system, the B system, it is all converting to work. Because that heat should go somewhere. Now, if it is not increasing the temperature, that means what it is doing? It is getting converted into work. Yes or no? All of you agree with this? Is it convenient? Yes or no?
Yes, sir.
Yes, it is
sir.
convenient. Okay, what about Nehra? You agree?
Yes, sir.
Yes, na? Because if you are not heating it, if you are heating it and it is not changing the temperature, it means what? It means that it is converting everything into it is doing something with that heat. What it is doing, we'll say it is doing all those heat into work, That means I can say, for an isothermal expansion, the Q, whatever the Q is, it is equal to what? It is equal to the work done. Okay, the work done. The Q will be equal to, now you will be a bit weirded out, but this will be equal to minus of W, because work is done by the system. That means it is giving out energy. That is why I am writing minus W. And you all know that since W is equal to minus of P external into delta V. Now, this is something that you have to trust with me. Okay, trust me with this equation that this is correct. Okay, Nehra?
Okay, sir.
Okay, so P external is the pressure of external, and delta V is the change in volume. Now, this will be equal to, so minus W will be equal to P external into delta V. Okay, now, so we have to look at P external. Can you see anything regarding P external here, Nehra, in the question? Yes, Nehra. Anything? Do you see P external given in the question? Yes or no?
No, sir.
No, you don't. Okay. But Cham, do you know there is some pressure in Earth?
Yes, sir.
What is that pressure? What is that pressure?
So what?
What is that pressure? Do you know how much pressure is there in Earth? Nehra, right now you are experiencing some pressure. Yes or no? You don't feel it, right?
Sir.
You feel
No.
that. Okay, fine. You don't feel it, but there is some pressure now which is exerted on you. What is that pressure?
Yes, sir.
Atmospheric pressure, right? You have
Yes,
heard
sir.
this atmospheric pressure, right? Okay, and that is 1 atm, na? Acha, will you have and will you experience the same pressure in moon?
No, sir.
No. Okay. Why?
Because there is no atmosphere.
No atmosphere. Okay. Now read again the question and see and tell me if there is any word which you can relate to external pressure. Read again the question. You guys also, okay? Asma, Hamza, Khalid, Salman. You guys also read the question and write in chat if you see any word in the question which can be related to the external pressure. Which can be related to external pressure.
Sir.
Chat.
Oh, okay.
Chat.
Okay.
No. That is the pressure of gas. Yes, Asma is correct. Asma, can you give them a bit of hint?
Sir, how do I give them the hint?
Acha, I gave you some hint. Yes or no?
Yeah, but then how do I add on to it?
Acha, how do you add on to it? Okay. Nehra, you can't see any word which can be related to external pressure?
Sir, is it vacuum?
See, correct. देखिए आपको तो आने लगा ना thermodynamics. This is your first class and you have not even spent 30 minutes and you are identifying which words are important. Now tell me what will be the external pressure, Nehra?
10 liter.
10 liter. Did you say 10 liter? नहीं. Okay, now again. Pressure na pressure. Liter to volume हो गया. You are answering big things. Okay. In space, what is the pressure? Is there any pressure? No, na?
No, sir.
है ना? Okay. So in vacuum also the external pressure will be 0. Okay.
Yes.
You understand this or you're just agreeing with me?
No, I understood.
I understood it. Huh? Okay, fine. So can you see that? I mean, in thermodynamics, these words are more important than the numbers in numericals, right? Can you see isothermally was a word which was more important than the numbers, any number till here. It's again, vacuum is more important. The word vacuum is more important. Okay. So here what I can write is P external is 0. And let us not worry about delta V because whatever multiplied to 0 will be equal to 0. Okay, now that means the Q, which is equal to minus of W, is equal to 0. And hence I can say that heat absorbed is equal to 0. And similarly, work done is also equal to 0. Okay, the work done is also equal to 0. What does it mean? It means that you don't have to give any heat. You don't have to give any heat to a gas which wants to expand in vacuum. It will be obviously going up and it will be taking up all the space at once. You don't have to give it any heat. You don't have to give it any heat. Okay, so please write this down. Let me know if you're done. So see, this equation is coming from where? This equation is coming from isothermal expansion. Okay. Now, as you can see, that delta U will be equal to Q plus W. Now, this will be equal to how much? 0, right? So again, for an isothermal expansion, the change in internal energy is 0. This is also one of the conclusions that you can write. Delta U will be equal to 0 for an isothermal expansion. Okay, so thermodynamics is intuitive. Okay, don't worry much about thermodynamics. It is one of the intuitive topics in chemistry. Okay, done, all of you? Can I move on? Asma, Nehra, Hamza?
Yes, I can move on.
Yes, sir.
Yeah, okay, fine. Now, in the same, we have a second question. Let us write, again, how much heat is absorbed and how much work is done if the gas expands at a constant pressure of 1 atm. Okay, at constant pressure of 1 atm. That means everything is same. The gas is still expanding. The gas is still expanding what? Isothermally. Okay, it is still expanding isothermally. Hence, I can say isothermal expansion. The change in internal energy is equal to 0. That is equal to Q plus W. And hence, I can say Q is equal to minus of W. And hence, P external, which is equal to P external into delta V. Now, here the P external is 1 atm. And delta V is what? The final is 10 liter minus the initial, which is 2 liters, right? Now, this will be equal to 8 liter ATMs. Now, one thing that you need to trust with me is 1 liter ATM is equal to 101.3 joules. So I can say 8 into 101.3 joules will be the heat absorbed by the system. If you calculate this, will be equal to how much? I think 810.4. 8 is a 24, yeah. Joules. So this is very similar to the previous one. Here just we have 1 atm constant external pressure, right? There's nothing we have changed. The concepts are same, but we have plugged in atm. Write this down. Let me know if you're done. So I can say that heat absorbed is equal to 810.4 joules and work done is equal to minus of 810.4 joules, right? Because this is nothing. This is Q is equal to minus of W. Whatever heat is absorbed, if you just give a negative sign, that will be work done. Okay. Can I move? Yes or no, guys? Nehra, Asma, Hamza.
Yes, sir.
Okay. Nehra, what about you? Did you write this?
Yes, sir.
अच्छा कॉपी तो लाई है ना आप कि कॉपी भी नहीं लाई है?
Sir, I will.
अच्छा you have got it, okay. So you have been in Dammam since your birth or
Yes, sir.
since your birth only? Okay. And you have studied in the same school?
Yes, sir.
अच्छा यहाँ भी है इंडियन इंटरनेशनल स्कूल वाले ही है हमजा हिबा बट Khalid and Salman, these guys are from Bahrain. In Bahrain, do you have Indian international school? Khalid?
I think no.
No, there is
No.
new Indian school here.
There is new Indian school. अच्छा. And Asma is from MES. MES का full form क्या है Asma?
वही तो सर फुल फॉर्म ही नहीं है, it's MES Indian School.
Full form ही नहीं है. What do you mean? Like it is.
I don't know. Nobody really knows what MES actually means.
Maybe
It's
Middle
just
East school.
Middle East. My sister's input also, sir.
Middle East school.
ये तो आपके पीछे से कोई बोल रहा है मिडिल ईस्ट स्कूल.
वही सर यहाँ पे बहन खड़ी हुई है.
अच्छा अच्छा. But I mean, it is a very redundant na, if you have MES school. So Middle East school. I don't think it is like that. So MES is in Qatar.
No, so
MES.
like in ours also it is IISR, I mean International Indian School Riyadh. So
I know.
like that will be MES means maybe Middle East school, because here also we have Middle East schools.
No, but it is not. There is M.E.S. But it is not an abbreviation. I don't know. So nobody knows it. So it is one of those mystery things of a particular school. All school have something. Achha, for example, like in India, all of these schools, they are made on some cremation land only. Is it true in Saudi also? I mean, because in India, all of the school, they will have one story. यहाँ पे पता है पहले शमशान घाट था फिर उसके बाद स्कूल बन गया. Do you have these stories in Saudi also? In the Middle East?
No, like
No.
here we have like different buildings and they have been rented and then mostly rented and like that. Mostly rented.
Achha. नहीं, it is not a serious thing that all these schools in India have been made upon Samshan Ghat. No, that is not true, but that is something which all of
Yes,
people
sir.
say.
I have heard that. Like my friends used to say when I was in school, यहाँ पे ये पहले कब्रिस्तान था, and I was like, आप बकवास कर रहे हैं.
How much heat is absorbed if expansion is conducted? If expansion is conducted reversibly at 298 Kelvin. Okay. Now, Nehra, here you have to trust me. Okay. I mean, because you have to trust the equations here, not me, because we have derived this equation in the previous class. Now, everything is similar. So again, I can write the answer here is in isothermal. So till here, you would understand in isothermal expansion. Delta U is equal to 0, which means that I'm not increasing any temperature. Delta U is equal to 0. That means the internal energy of the system is equal to 0. It means that Q plus W is equal to 0. And hence I can say whatever heat is given, it is utilized by doing work by the system. And the formula for this is 2.303 nRT log V2 upon V1. Okay, now you can just substitute this as 2.303 and nRT can be written as PV log V2 upon V1. Here you can write 2.303. The pressure is Pressure of the gas is 10 atms, right? Into the initial volume is 2 liters into log of 10 upon 2. Okay. Now this will be equal to 2.303 into 10 into 2 into log of 5, which is equal to 0.7 liter atm. Now to convert this, I will have to write 2.303 into 10 into 2 into 0.7 into 101.3 joules. So you can calculate this and tell me what is the answer. Send the answer in chat, okay? So, yes, Khalid, correct. This will be equal to 3266.1 joules. Yes, Hamza, correct. Okay. Now, since this W is reversible work, okay, I hope you guys remember the formula for reversible work. This is Q, which is equal to minus of W reversible. And hence I can write heat absorbed is equal to this much. And work done is equal to the negative of 3266.1 joules. Okay, so we have this equation, which is delta U is equal to Q plus W. And also we have the same formula. We can write this as delta U is equal to Q plus minus of P external delta V, which is volume. Okay. Now, if I have isothermal process, then we have just seen na Nehra, do you remember what will be delta U equal to if it is an isothermal process? Yes, Nehra. You can look above the notes, okay, and tell me.
Yes, sir.
Delta U will be equal to, if isothermal process is there, look in the notes. The questions that we did now.
Q plus W.
Sorry, Miss Nehra. In isothermal process, delta U is equal to, we have done now, it is equal to 0, right? The change in internal, or rather I should say isothermal expansion, not process, isothermal expansion. The delta U is equal to 0 and Q is equal to minus of W. Okay, Q will be equal to minus of W. Now, if I have isochoric process, isochoric means the volume remains constant. Delta V is equal to 0. Now, if delta V is equal to 0, then I can say that this part of the equation will be 0, and hence the Q will be equal to, hence the delta U will be equal to, I can say Q. And let us name this heat as QV, which means the heat at constant volume. If I heat at constant volume. Now, we can also classify one more thing, which is if you have free expansion. Free expansion, it means expansion without any external pressure. Now, if P external is 0, that means this P external, this part is 0. And again, we can say that delta U will be equal to Q, delta V equal to Q. Now, there is one more thing that we will write, but we will write that later, okay? We will write that later. So just write these three things and tell me if you all understand this, yes or no, okay? Asma, Hamza, Heba, Khalid, Salman, Nehra, all of you, okay? Tell me if you understand these three parts, yes or no. Ha, guys, tell me, you understand this, no?
Yes,
Any
sir.
doubt here?
Yes, sir.
Okay. No doubt, okay. Let me know if I can move. Okay, Hamza is done. What about others? Khalid is done. Yes. Asma, done?
Yes, sir, done.
Okay, fine. So now think about these things. Now, isothermal expansion, it means you're heating, but the temperature is not changing. You must never have seen this happening, even though you have used the gas stove many a times. The volume is constant, never happens, right? Because, volume can never be constant if we are doing chemistry, because we do chemistry in beaker, and obviously in beaker, the volume can rise and it can get lowered also. Again, free expansion, it is only possible if we are doing experiments in the moon, where the external pressure is 0, or we are creating a laboratory in which there is 0 atmospheric pressure, right? So all these cases are very extreme cases, and I hope you can see that you have never experienced this. Yes or no? Think about this for a few minutes. Okay, isothermal expansion, the temperature does not change. You are heating, but the temperature is not changing. Isochoric, in isochoric you are not changing the volume, and in free expansion the external, this is so never can happen in reality, right? Free expansion only will happen if you do experiments in moon. Okay, so tell me, all of you agree that all these cases are extreme cases? Yes or no? Yes or no, guys? All these cases are extreme cases.
Yes, sir.
You agree? Okay. Now, this is why all these cases are the cases of which are made by physics. That means in physics, you can do anything. No? You can write things only. Right? You don't have to do much of experiments there. That means you can write anything. But again, when I come to chemistry, chemistry is the science of most experiments, and that is why in chemistry only you will see someone wearing a lab coat, right? Okay, not to brag about chemistry, but let us start studying chemistry. Now, in chemistry, what happens? We do experiments, right? And in experiments, now let me draw a very bad beaker, let us say. So this is, let us say this is a beaker. It has some knob here, and okay, yeah, that is our beaker, okay? And inside this beaker, I will have some, I hope this is green. Okay, I don't know what color is this. I'm not colorblind. My computer is colorblind right now. In evening, it becomes colorblind. It cannot differentiate between blue and green.
You mean you enabled night mode?
In night mode only. That is right. Happens. Yeah, correct.
It's yellowish everything.
Yeah. So let us see. Suppose that there is some experiment which is happening here. Okay. So there are a few things. For example, what can happen is you have pressure, the external pressure, then you have volume, then you have temperature, right? Then whatever heat is involved in this particular thing. Okay, now what do you think? What can you say something which will be always true if you're doing an experiment in an open container? Can you guys tell me? Think about the external pressure now. Think about the external pressure. Can you guys tell me what will be the external pressure if I am doing something in the laboratory in the open? The volume can change by what container you're taking. The temperature can also change. I mean, yeah, okay, fine. Temperature, you can see it is somewhere around 25 degrees Celsius, okay? The room temperature. The heat can change if you're using a burner or if you are not using a burner. Tell me about the external pressure. What will be the external pressure? Send me in chat, but okay, don't say it out loud. I want all of you to think. No idea. External pressure, guys. Okay, so Asma, if you're doing an experiment in the laboratory, then answer me one thing. Can you turn the mic on?
Yes, sir.
You will be experiencing some external pressure, yes or no?
So could you repeat?
Will you be experiencing any external pressure? Not emotional, by the way, the physical pressure.
Yes.
What pressure?
I'm not sure.
Acha, but you think you will be experiencing. Are you guys experiencing any pressure right now?
Atmospheric pressure?
Exactly. Na? So if you are doing anything in the laboratory in the open, we will be always experiencing some external pressure, right? All of you
Yes,
agree?
sir. Yes, sir.
1 atm. So that means the external pressure is constant. Yes. What about others? Hamza, Hiba,
Yes, sir.
Nehra, Anna. Now we haven't talked about internal energy when the external pressure is constant. Okay. So now we have put on our chemist hat, and what we are going to do, we are going to derive a few things regarding delta U, which is equal to, okay, I forgot my U. The change in internal energy is only due to some involvement of heat and the involvement of work. Involvement of heat and involvement of work. Now, rather than writing Q plus W, I should write this as Q plus the negative of P external delta V. P external delta V. Okay. Now, what is delta U? I can write this equation as U2 minus U1. Right? Delta U is U2 minus U1 is equal to Q minus. Can I write minus? Yeah, I can write minus. No. P external. And for delta V, I can write V2 minus V1. Okay. Now, again, U2 minus U1 is equal to, I can write Q. Then I can write the negative of P external. I can get this P external inside. I can write this P external into V2 minus P external into V1. Okay. So yeah, I think we have not violated anything in mathematics till now. And we are not going to, we cannot violate anything in the mathematics. Now, what I can do is, I can take this whole term with the negative sign towards U2 minus U1. Okay. That means I will be keeping the Q this side and getting this here. So this will be equal to U2 minus U1 plus P external into V2 minus P external times V1. Now I can write this as, see, I will be just changing a few things. U2 minus U2, and let me write this as U2 plus P external into V2. Okay, so I have not violated any mathematics. U2 was positive here. P external times V2 was also positive here. That is why everything is fine. Now, minus, I will write U1. See, U1 is negative here. U1 was negative here also. Then I can write what? Plus P external of V1. So P external was minus here, and minus into positive will be negative. Okay, so we have not violated any mathematics till here also. Now what I do, I see that this is something internal energy plus P external times V2, and this is internal energy in the initial state, P external times V1. What I can see is that I can give this a new term, and I can write this simply as H2, and I can write this as H1. Okay. Now, since the external pressure is constant here, what I can write is this is QP. It means the heat at external pressure, at constant external pressure. Okay. Now, I can write this as QP is equal to delta H, and I have to also give this term a particular name, and this is named as, this H is named as, the H is named as enthalpy. Okay, enthalpy. So enthalpian, it's a Greek word which means to heat, and from there we come to enthalpy. Okay, so now all of you please tell me, is enthalpy a real thing or it is a mathematical term? It is a mathematical thing. Can you tell me? What do you guys think? If I have to define enthalpy, then it is not something which is very real, right? It is what? It is the sum of internal energy and the product of P external times the volume, right? So enthalpy, it is not something that you can very much feel. It is very mathematical. Okay, it is very mathematical. And why did we need enthalpy? Because we had to shorten this term, right? This was a very big equation, so we needed to shorten this, and that is why we introduced a term which is H, and we call that enthalpy. Okay, we call that enthalpy. So enthalpy is nothing else. It is just that. And delta H is what? Change in enthalpy. Change in enthalpy. So just a request, please don't try to feel enthalpy. Enthalpy is mathematical. Okay, the same way you don't try to feel sine theta, no, because it is very mathematical. That is why please don't try to feel the enthalpy also. Okay, you will not be able to feel enthalpy. Okay, please let me know if I have to scroll up or down. Okay, we have a new participant here. Yes, Subhan Mishra, how are you? Yes, hello Shobhan, can you please turn the mic on?
Yes, sir. Yes, sir.
Yeah, so you are here for which class?
Sir, I think this is not my class. I'm from 8th. I believe.
Yeah, please leave. Okay. Let me know if you guys are done writing, okay? Okay, Hamza is done, Hiba is done. Waiting for Asma, Khalid, Nehra, and Salman. Yes, guys, done. Can I move on? Yes or no? Done. Okay, Nehra. So Nehra, just to ease things out for you, you can just raise your hand if you're done, okay? You can just raise your hand. Okay. So delta H is enthalpy. Let us now start writing with me the definitions of enthalpy and so on. So write enthalpy. Enthalpy is defined as the sum of, enthalpy is defined as the sum of internal energy and product of its pressure and volume. Okay, that is enthalpy. That is enthalpy. Now, since enthalpy depends on U, which is internal energy, comma, pressure and volume, which are state functions, and hence H is also, that means enthalpy is also a state function. Okay, so all of you have heard this word, right? Enthalpy, ionization enthalpy, electron gain
Yes, sir.
enthalpy, right? So now you know what enthalpy is, right? Now all of you know what is enthalpy. So enthalpy is the energy. Enthalpy is the energy of chemistry. Why? Because in chemistry we always have the P external, which is a constant, okay, which is 1 atm, and that is why we use the word enthalpy, which is mathematical and not simple energy. Okay, let me know if you guys are done. Okay, Salman is done. Okay, Nehra is also done. Okay, fine. Can I move, Asma?
Yes, sir, I'm done.
Okay, done. Now let's write the relationship between Nehra. You're understanding? Are you following me? Yes or no?
Yes, sir.
But you need to look at the previous videos, okay? The lectures, they have been recorded and you should look at them. Are you in contact with Nishkar sir, or did you get this link from someone else? Yes, Nehra.
Yes, sir, I don't know.
You don't know? फिर आप कैसे आई यहाँ? Who gave you the link, Nehra?
Sir, my mom gave the group, you know.
Acha. So, okay, fine. Then I will ask Nishkar sir to get in contact with you and he can send you the previous lectures, okay? And you watch them, fine?
Okay, sir.
Okay.
Okay, sir.
Now, relationship between enthalpy and internal energy. Enthalpy and internal energy. Okay. Now, since we have put on our chemist hat, what we can do is we can start with a reaction, a hypothetical reaction in which A is giving B. So here I can write the delta H is equal to the final enthalpy minus the initial enthalpy. But again, we are not very much interested in the absolutes. I mean, this is just a definition of delta H. This is not a formula. And as we know that H is equal to U plus PV, what I can write here is HA is equal to internal energy of A plus P, not pre of A, because P external is constant, that is 1 atm. Okay, that is P into volume of A. Okay, volume of A should be there. Similarly, I can write HB, which is equal to internal energy plus the product of pressure and volume. Okay. Now let us substitute this. Let us plug in these values into delta H. So delta H is equal to UB plus P VB minus UA minus PVA. Now here what I can write, it is equal to, this is equal to UB minus UA plus, can I write P into VB minus VA? All of you guys see this and tell me. And this I can write as delta U plus P delta V. Another important equation. This is how we are going to calculate. This is a formula now. Okay. The previous one was not a formula. It was just the definition of delta H. This is the formula now. Okay. Now, since all of you know that as I can write PV is equal to nRT. PV is equal to nRT. What I can write about P of VA, which will be equal to, since R is constant, the temperature will be constant. I can write NB. Sorry, volume of A is there. Then I should write NART, and PVB will be equal to NB RT. Now I will put this in this equation, and I can write UB delta H is equal to delta U plus, what I can write this equation here now, P in PVB minus PVA, it will be equal to, write it like this, PVB minus PVA, this will be equal to delta U plus PVB is NBRT minus NART. Then I can write delta U plus NB minus NART. This will be equal to delta U plus delta N. Now please remember that this will be only valid for gas because we have taken the ideal gas equation. That is why I'm writing the subscript. The number of change in the number of moles of gas times R times T. Okay, so another important equation. So we start from something which is very intuitive, but then we have to boil down some mathematics, because again, mathematics, you can plug in values and directly write it. Okay. So this is simplification in terms of experiments, but it is not simplification in terms of theory. So you must be thinking that the initial part was easy, but it is of no use because we can't plug in direct values if I'm doing any experiments. Now this equation can be used in any experiment and we can calculate the delta H. Okay. So even though it is bigger than the previous one, it is more important. Write this down.
Sir, what is NG?
NG is change in moles. So, okay, I will write all these stuff. Okay. So if you're done till there, then I can write all these terms. Okay. So what is delta H? It is energy change at constant pressure. Okay, constant pressure, which is equal to delta U. What is delta U? Delta U is the energy change at constant volume. Okay, and what is delta Ng? Now write plus. What is delta Ng? It is change in the number of moles of gas times R times T. Let me know if you're done. Okay. Okay, so I think most of you are done. Now, let us see. Let us see here. Okay. Asma, can I have you, please? Miss Asma?
Yes, sir. I couldn't
Hmm.
hear you.
Yeah, I'm just asking you to turn the mic on. Let
Yes,
us
sir.
say that if you have a reaction in which the change in the number of moles of gas is equal to 0, okay,
Mhm.
then this whole term will become 0, yes or no?
Yes, sir.
That means delta H will be equal to what?
Delta U.
Delta U. Okay. Now let us suppose that if delta Ng is negative, then this whole term will become negative, yes or no?
Yes, sir.
Okay, now you tell me, delta H will be bigger than delta U or smaller than delta U?
Smaller than delta U.
Yeah, smaller than delta U, because it will be something less than delta U. Okay. Now delta Ng, if it is positive, then delta H will be
More than delta U.
more than delta U. Very good. Okay. Now write these all of you, and then I'm writing a question. Please write. The heat of combustion of methane gas. What is methane? CH4. At constant volume is measured to be minus 885.4 kilojoule per mole. Kilojoule per mole at, let us say, 298 kilo. Find the value of enthalpy change. Let me know if you're done writing this question. Yes or no.
Sir, could you go up again? I got disconnected.
Sure. This much? I think this much is fine for me. Done?
Yes, sir.
Now write this question. Done, all of you?
Yes, sir.
Okay. Nehra, can you please turn the mic on?
Yes, sir.
Yes. Okay. Can you read the question for me? And can you identify the things, the words that are important? And others can send the answer in chat. Okay. Hiba, most importantly, you don't answer anything in the class. Nehra, did you understand my question? What did I ask? Asma, what about you? Did you understand what I asked?
Yes, sir.
You have to tell me the important words in this particular question. Nehra, can you find any? Please start. Hamza, Hiba, Khalid, and Salman also. I am not seeing anything. Neither in the chat nor from Nehra. Yes, guys, you can't find any word which is of importance in this question.
Sir, everyone, like,
Every word.
no, like every one of us.
What you guys can't find, na? That is what you're asking.
Oh, okay,
Telling
you
me.
asked us also. Okay, sir.
Yeah, that is what
First
I was
is
saying.
combustion of methane.
Arey bhai, in the chat, bhai. That is correct. Yes, Nehra, can you see that combustion is important?
Yes, sir.
Okay, so combustion is a reaction, right? Yes or no?
Yes, sir.
A reaction with? A reaction with? Yes, Hiba, combustion is a reaction with? Hiba, tell me. Yes, Hiba, combustion is a reaction with? You don't know. Hi, Hiba.
Sir, with oxygen.
Yeah, very good. So you have CH4, which is a gas, okay, plus O2, which is again a gas. They both will react. Now see, you also have to understand, you also have to have a knowledge of the reactions now. A carbon, when it reacts with oxygen, it will become carbon dioxide, which is a gas. plus it will give me water. Please remember that the temperature is 298 Kelvin. That means, yes, Asma, very good. Now H2O at 298 Kelvin will be liquid, gas, or solid? Tell me. Anyone? Water at 298 Kelvin will be solid, liquid, or gas? Yes, Nehra, Khalid, Salman. What happened? Water, H2O at 298 Kelvin will be a solid or a liquid or a gas?
So liquid?
Liquid, right? Very good. Thank you, Asma. Okay, so this is liquid. Now we have this particular reaction, and they have asked us to calculate the enthalpy change, right? We all know that delta H for a reaction which involves gas, you will always write it something like this, which is equal to the internal energy change plus the change in number of moles of gas times R times T. Times T. Okay. Now, can all of you see that what is delta U? See here, they have said at constant volume is measured to be minus 884 kilojoule per mole. And we have just written what is delta U? Delta U is nothing but it is the energy change at constant volume, right? So they have told the heat of conversion of methane at constant volume is calculated to be minus 884. That means it is the energy change at constant volume, which is equal to minus of 885.4 into 10 to the power 3, because it is kilojoules, all right, joules, plus what is delta Ng? Okay, now we have to balance this particular reaction. So I will write 2 and then I will write 2 here. If you have the number of moles of reactant, this is only 1 mole. So it is only 1 mole, no? Sorry, product. Product is only 1 mole, right? Yes or no? Only 1 mole, no? Yeah, 1 minus.
Yes, sir.
And how many moles of gas here? Here it is 3 into R times T. What will be R here? 8.314 into temperature is 298 Kelvin. Okay, so whatever you will be getting, it will be in terms of joules. Okay, minus 885.4 into 10 to the power 3 joules, and then you have minus of 2 into 8.314 into 298 joules. So this is what, minus 885.400 joules, then again minus 2 into 8.314 into 298 joules. You calculate this and tell me what is the answer.
So we should send final value of enthalpy change, right? In chat?
Yeah. Just send me the final value of enthalpy change. Yes, Khalid, correct. Yeah, Asma, correct. Yes, Hamza. So it will be equal to 890,355.144 something joules. Now this will be equal to 890.3 kilojoules, right, per mole. I have to write per mole also here. Just let me know if you're done. So this is how you have to understand the question and do it. Okay. So once you recognize the important word in this particular question, the math, I mean, whatever the equation that you are using, those are not very tough. Okay. Those are easy only. Done, guys? Done. Or no?
Yes, sir.
Done, sir.
Done. Okay. Now, see here. Now I can write way above here. Right. Yeah. Here I can write that if you have constant, like if you have constant, P external is constant. In that case, we have delta H, which is equal to Q, right? Which is equal to QP. Okay, and we can also write which is equal to the delta U plus delta NGRT. Okay, this is one of the important remarks. Please write this down, the label there. So chemists are more interested in this part, delta H part. Okay, you will be seeing very less question in chemistry involving these three parts: isothermal expansion, isochoric, and free expansion. In chemistry, mostly deal with delta H.
Sir, could you show the constant px again?
This is QP. It means what? It means that it is the heat at constant pressure. Yeah, let me know if you're done. Done, guys? Yes or no?
Yes, sir.
Yes, sir. Done.
Okay. So we have delta H, which is equal to delta H, and now this has two formulas. No, let me write it like this: delta H. It has two formulas. Okay, which is delta H is equal to delta U plus P delta V. Similarly, delta H is equal to delta U plus delta NG RT. Okay. Now let us see if in a reaction, done in closed vessel, right? That means the change in volume will be equal to 0. Yes or no? Because it is closed. If the change in volume is equal to 0, then I can say that delta H is equal to what? Delta U, right? It is equal to delta U. Now, if I will say a reaction that does not involve gases, in that the number of moles of gas in reactant will be equal to number of moles of gas in product, which will be equal to what? 0. Now again, if I put 0 here, then again delta H is equal to delta U. Okay. Now you can write the last part, reactions that involve equal number of moles of gas in reactant and products. In that, what will happen? If the number of moles of gas in the reactant is equal to number of moles of gas in product, then delta Ng will be equal to 0. And then again, delta H will be equal to delta U. Correct? One of the example of this is if you have H2, which is a gas, you add to it Cl2, which is also a gas, you will get 2 moles of HCl gas. Now here you can see that there are 2 moles initially, and there are 2 moles of gas after also. Okay, these are 3 particular cases in which delta H is equal to delta U. Write this down, let me know if you're done. Done guys, yes or no?
Done, sir.
Done. Okay. What about others? Nahara. Nehra, not Nahara. Nehra. What is the meaning of Nehra? Nehra, what is the meaning of your name? You don't know?
So maybe river.
Nahar. Nahar se.
Yes, sir.
I don't think.
Nehar and Hara. Or maybe daylight or something. From Nahar.
Al-Nahar. Layl wal Nahar, na? It may be. Nehra, you don't know the meaning of your name? Acha. Do you know if it is Ha or it is Ha in Nehra? Is it like Ha or it is Ha? Choti Ha, badi Ha. I mean, you don't know that. See, I can't even hear your voice properly. Is it an Arabic name or is it a Urdu name?
I think it's an Arabic name.
It's an Arabic name. Okay. There is, I mean, it also means sacrifice, I guess, na? Hamza?
Sir, that is Badi Ha.
Like it is Ha.
Like, yeah.
Alhamdulillah wala, na?
Yes, sir.
Achha. But if it is, and if it is Choti Ha, for example, like in, I don't know, I can't think of an example, then it will be Al-Layl wal Nahar. It will be day and night. Okay. Asma, do you know what is the meaning of your name?
Yes, sir.
Now tell me.
It just means name.
Yes.
I've
Okay,
been
I'm
really
glad that
angry
you-
about my name my whole life.
Yeah, what is the meaning? It's my name. Okay. So as ism means name, right? I mean in Urdu also ism. Like if you go to, not right now, but I think if you were to visit Lucknow in like, you don't know, maybe 20 years back also, then they would have asked you like, "Aapka isme grami kya hai na?" Like, what is your beautiful name? So they asked like, "Isme grami kya hai?"
Yeah, sir. In tier class, I had Arabic. So in introduction class, our teacher would ask, "What's your name?" And we had to say, "Ismi Asma." So technically, I just said my name was name.
My name was name. Ismi Asma. Yeah, correct. ISME. What is that? What is that thing called? ISME, na? ISME. That this E is known as what? I forgot that. ISME. If you have to, we have to conjugate two things. Fair. Let me not scratch my head with Arabic right now. Okay. Now we have to learn about something. For that, let us suppose you have a cup of water. You have a cup of water. Okay. Let's suppose you have a cup of water here, and which is holding, let us say, 100 ml maybe. And then you have a utensil. You have a utensil of water. Okay. And this is holding, let us say, 10,000 ml. Okay. So 10,000 ml. Now, I want to boil both of them. So obviously I have to give some heat. I have to give this particular water also some heat. Okay. Now, what do you think in case A or case B? Which will require more heat to boil? Which will require more heat to boil? Tell me. I don't know. A or B? Yes, Hamza, correct. What does Nahra, what do you think? Yes, Hamza. Yeah, yes. Yes, Siba. Yes, Asma. Correct. Okay. Nahra, what do you think? Is Nahra not here? Which will require more heat to get boiled? Which will require more heat to get boiled?
The B1.
B1, right? The B1, correct. Now, by the Asma, you have a little sister.
Yes, sir.
Which class is she in?
6th grade.
Acha, she's in 6th grade. Okay.
And an infant, but yeah.
Acha. No, I have a cousin. She was here. She's also in MES and she's in 7th standard. So I thought maybe your sibling maybe must be knowing. Okay. So heat, and we have the B1 which will require more heat. That means, can I say that this tub or utensil of water, it can hold more heat? Can I say that it can hold more heat? It has higher capacity to hold heat. All of you agree with all these things that I have written? Yes or no? Yes or no, guys?
Yes.
Yes, we
Yes,
all
sir.
agree. Now we are talking about the same thing, which is water, but it has a property which depends on the mass of the water, and that property is the capacity to hold heat. And if I see that term, it is known as heat capacity. Okay. So now we are going to learn about the heat capacity and the things which determine heat capacity. So heat capacity are different things. Heat capacity. Now, what is heat capacity? If I heat something and if I heat it more, then I can see that change in terms of temperature. That means if the temperature is changing more, that means I am heating it more. So I can say that Q is directly proportional to the change in temperature. And if I have to put a equality sign here, then I have to put a proportionality constant. Let us call that C into delta T. C into delta T. And this particular term C, it is known as the heat capacity. Okay. How much heat can a particular substance hold? So you can write the coefficient C is called heat capacity. It's called heat capacity. Okay.
So is heat capacity intensive or extensive?
It will be extensive only. Now, see, it is depending on the amount of water.
Yeah. Okay.
It is heat capacity. Now, if I will say if the C is larger, then a given amount of heat will result in small rise in temperature. है ना? That means you can see, for example, what is heat capacity? Heat capacity, na, you can think in terms of like if you are trying to heat it, but it is not showing change in temperature. That means it has higher heat capacity. है ना? बहुत मोटा चपड़ा. आप उसको जितना भी चिड़का लो, आप उसको जितना भी I mean, no matter how much you tease them, they don't get agitated, right? That means their capacity is more to, I mean, for getting agitated. Similarly, in heat capacity, if you are heating it, if the heat capacity is larger, that means you can heat it for a very long time, but there will be not much increase in the temperature. So you can see that mathematically, C is equal to what? It is equal to the Q, the heat given, divided by delta T, right? That means if this is very high, obviously it means that the delta T should be low. The delta T should be low. Now again, if I have to say that, let us say, if the change in temperature, I gave some heat to a system, and the rise in temperature was of 1 degree. Okay, if it was 1 degree. Now, what I can say, C is equal to Q when the change in temperature is 1 degree. Now, this is how we define constant. So I can say heat capacity is the amount of heat. Is the amount of heat required to raise the temperature, to raise the temperature of a system by 1 degree. Okay, so please write this down. Let me know if you're done.